was too good, that your consultants complained that they never got around to coffee because their queries finish way too fast, attend this session to find out how to solve this. Use user-defined functions to kill your performance in one easy step. Or perhaps not. We're going to talk about user-defined functions, but first a bit about me. My name is Hugo Kornelis, and I make SQLServerFast.com. SQLServerFast.com is a website where I build the execution plan reference. All my career in SQL Server, I've been obsessed with performance, and as an extension of that, I have been obsessed with execution plans. Execution plans are the gateway to understand why queries don't perform as fast as they should. Unfortunately, the documentation that Microsoft provides on execution plans is lacking, and that's why one day a few years ago I decided to build a complete reference website where one day in the future you will be able to find everything related to execution plans. Because a reference is not a good starting point for people learning to work with stuff, I have also been asked to provide more training material, and I've started recording a series of videos. The first block of videos is a free gift of me to the community, but given the time I spent making those, I cannot give them away, all of them, for free. But because I love all of you for being here, I have a special discount code that is valid until the end of the month. So if you're interested in subscribing to my videos, you can now for this month get 10% discount using the code DataFrogs. On my website, I have a lot of other content as well, like my blog, like my articles, but the most important, if you want to download the slide deck or the demo code I'm going to use in this session, or for any other session, just go to SQLServerFast.com, use the menu to go to other presentations, presentation resources. You can download the slide deck, you can download the demo code, you can play with it to your heart's content, do with it whatever you like. It's all for the community. I do a lot of other stuff as well, for instance, try to make money, but you don't care about that. What you care about is that you can mail me at hugo@perfect.info or tweet me at Hugo_Kornelis. If there are any relevant questions relating to what I do for the community, I will try to answer them. If you don't get an answer within 2 or 3 weeks, I've probably forgotten it. I got swamped. It happens sometimes. Just send me a quick and friendly reminder and I will try to get back to you. Anyway, we are going to talk about user-defined functions. But before I dive into the content, if you have any questions, please just type them. There should be a chat window or a question window somewhere. I'm sure you've done the drill today all day already. So just type them and Rudy Bruchet will read them to me and I will try to answer them during my presentation.
Yes, I added the link in the conversation.
Thank you very much, Rudy. So the agenda for today, we are first going to talk about what is a user-defined function. And after that, because we all love demos, it's demo time. Obviously, at one point the demo ends and then we'll just do more demos. After that, there's the conclusion. So yeah, you can download the slide deck, but actually for this presentation, you want the demo code more than the slide deck. Again, it's all available, but there's not much slides. It's mostly demos what I'm going to do. So what is a user-defined function? And if we were in a live room now, I would ask people to suggest something, but that's not going to work in this remote format. So I'll just give my answer straight away. A user-defined function is like a black box. It's a box that contains functionality. We don't care how it's implemented. We care about input and output. A user-defined function has a specific definition of what data you feed it, and what comes out of it. How it works internally is irrelevant, and that is great for reusability. Developers love user-defined functions because it gives them reusable code. They build it once, they test the heck out of it, they deploy it, and then they can use it everywhere and know that the correct result will come out every time. And if it ever needs to change, they open the box, they change the internals, they test it again, they deploy it, and everything works again. That's the awesome thing about user-defined functions. But there is a downside, and to see that downside, let's dive into the demo. So here's my demo. And for this demo, I've set up a scenario. So I am a database developer for AdventureWorks Cycling Company. Why am I a database developer for AdventureWorks Cycling Company? Why not for another company, you might ask? Well, that's the question I always ask myself when I did Microsoft certification exams, because they always start with, you are a database developer for AdventureWorks Cycling Company. So yeah, I am apparently a database developer for AdventureWorks Cycling Company. And one day, I am just doing my own thing, hard at work, or perhaps watching some cat videos while my boss isn't watching, and suddenly my boss approaches. So I quickly switch windows, pretend I'm actually working, and my boss tells me, Hugo, it's that time of year again. We need to discuss how the wages for next year will change. The boardroom is busy, they are discussing options, and we need you to do a projection. Because right now the boardroom is thinking we should cut the salary of sales representatives by 25% and instead give them a 25% increase in their commissions. We think that will make them work harder and they will increase sales by 50%. Now, of course, not everyone is in sales. So for the employees on an hourly rate, we want to increase their rate by 3%. And for the salaried employees, we are planning no change at all. Assuming that all employees work on average 1,800 hours per year, we need you to project what the total cost of all the wages and commissions will be if we do these changes, so that we know whether we can afford that change. Can you do that? And it's hush hush. It's still, we don't want the unions to know this yet, because we aren't sure yet whether we can even afford it. But can you do that? And I'm like, sure. Of course I can do that. I am a database developer for AdventureWorks Cycling Company. I can do this. So I quickly go to SQL Server the Management Studio or Azure Data Studio, whatever you like. And in the demo code, I have already run this code that is called prepare database. I'll show you what the code is, because I set up an empty database. I create some tables, and you can read it later. The details are not really relevant. And then once those tables are created, I fill them all by copying data from the AdventureWorks sample database that Microsoft released. But I do that 100 times. So I actually have 100 copies of the AdventureWorks data. Near the end, I do a select count star from all tables. And if you look at the results, you can see that I have almost 60,000 rows in the person table, 29,000 employees. There's a bit more pay history for each employee, a bit more department history for each employee, and we have 1,700 salespeople. Good. Now, let's first assume that I am a bad developer. Let's first assume that I don't care about code reusability. I just get started. I am the original cowboy, and I look at the demands. And let's just first make sure that I'm in the correct database. So I create this query, and this took me some time. It's a tough query, but I'll talk you through it. The basics is, of course, I want details for every employee. Now, for every employee, I also wanted to add the name so that I could quickly do my own quick check on whether the results are correct. So I added the name by joining to the person table. Now, I also need to know what the current pay of that employee is, but there is a history table that has multiple rows per employee pay history, and there is no specific column that marks a column as the current one. What I need to do is pick the row with the most recent rate change date. So in order to do that, I have a CTE here that adds a number starting at 1 and then going up, after ordering by descending rate change date. So the column that has row number 1 is the most recent changed. And I'm joining to that CTE with a filter on row number is 1. So this trick is how I get the most recent pay for the employee. And then I join to the salesperson table, but this has to be an auto join. I want all employees to be in my results. So I do an auto join so that if an employee is not a salesperson, the row is still there, but it will have no values for data coming from the salesperson join. Now, the actual select is rather simple. I do the business entity ID, the job title, I concatenate information for the full name, and here is where the magic happens. This is a rather complex formula, and this formula corresponds to the logic you see on the screen here, the logic my boss told me that the boardroom is now contemplating. So when the business entity ID is not null, that means, as Peter's the salesperson table, when the join to the salesperson table actually resulted in a row. If there was no match here, this would have been a null. If it's not null, then this is a salesperson. And before I forget, every time during this presentation you see the word or hear me say business entity ID, just pretend I said person ID. For whatever reason, I never knew why, but for whatever reason, Microsoft, when they created the AdventureBox table, created the person table with a primary key, not called person ID, but business entity ID. And that primary key was then inherited in the employee table and the salesperson table. So pretend it's the person ID of the salesperson table. If there's no row from if there is a row from the salesperson table, then we're going to use their hourly rate minus 25% times the 1800 hours. We're going to add the commission with a 25% increase multiplied by their last year's sales with a 50% increase. If it's a salaried employee, then their rate remains unchanged. If it's not a salaried employee, then they're on an hourly rate, then they get the 3%. Now, I always care about performance, so I'm going to run this with execution plan with actual runtime statistics included there as well. And you see the results come back pretty fast. And when I look here, I can see that the number of logical reads for each table corresponds to the number of pages they take up on disk. Every page is read once. Scan count 9 and not 1 is because the query runs in parallel. It's above the cost threshold for parallelism. So SQL Server says, I'm going to run this as a parallel plan to give you a faster response. And if I look at the execution plan, I see merge joins, I see clustered index scans, and I can scroll around a bit and look at the rest. It's all scans and merge joins. And for a query like this, where I don't filter, I process entire tables and I join it all together, I want an execution plan with scans and with merge joins or hash match joins. And I do not want inner loop joins, and I do not want seeks. Those are better for OLTP type queries where I select just a few rows. But here I really want this type of execution plan. So I'm pretty happy with myself. And of course, I tested that the results are correct. I used my calculator to verify a few. And then I go to my boss and I say, hey, boss, I've got the results here. Here. And my boss immediately covers their eyes and says, no, Hugo, you can't do that. We have GDPR here. You can't put the names in. Are you mad? Oh my God, totally forgotten. Of course, I should not have done that. I quickly comment out this line and run it again, and we will pretend it never happened. Whew. Now, you may have noticed that in my hurry to remove the name, I forgot that the person table is now not used anymore. There is nothing in the query that still refers to the person table. So you might think that the execution plan now does a needless join to the person table. But if I look at the messages, I see that the person table isn't read at all. And if I look at the execution plan, I see that it's smaller now. There's a branch removed, and also because it does less, it's now cheaper and it's now below the cost threshold for parallelism. It's now so cheap that we don't need to go parallel anymore. So even though I left this person table in, the optimizer looked at the query, was like, yeah, I'm not going to do that join. You tell me to join to the person table, but it's never going to affect the results. So why would I waste time doing something that will never affect the results anyway? And the optimizer saved my ass here. So now we have the correct results. But obviously, my boss will not want to go to the boardroom after printing out 29,000 rows of individual data, and my boss will not give the boardroom that stack of paper and a calculator to tally it up themselves. So my boss tells me, now what I need is not this detailed list, I need a total. So what I then did is I copied this query, just copy paste, remove the detail columns and added a sum around the computation. That's all the change I did. And okay, I now remembered to actually remove the person table. But basically it's a copy of the previous query with some modifications. And when I execute this, I get the total. And I can, of course, look at the messages tab and the execution plan tab. In the interest of time, I won't. It's still going pretty fast. And my boss brings this number to the boardroom. And even though there are very thick walls, they're supposed to be sound absorbing, I heard the muffling screams. I heard something was going wrong. So I was not surprised when my boss quickly returned and said, yeah, Hugo, the blame game has started. Can you break it down by department? Sure, I can do that. So I copied this query and still the same query with the sum, but now I added the department ID column, which I, of course, then also had to add in a group by. But the department ID comes from a different table, from the employee department history. And the employee department history, like the pay history, has multiple rows per employee. But a huge difference is that the employee department history has a convenient end date. So here I don't need this weird construction with the CTE. I can just pick the one row for each employee where the end date is still null. And I can run this query and I can execute it and I can look at the execution plan and well, there's a hash match now, but it's still doing scans, hash match, merge joins. The number of logical reads is still okay. Just every table is read once and here are the results. Now, while this was going on, my boss also told me, hey, while you're at it, once we are further ahead in the decision making, we will want to put out a web front end on our intranet where employees can get their own projection for what they will earn with the new ideas. The front end guys are already busy, but you know the drill. They need a stored procedure that they can call for the results. You trained them well. Start building. Now, for this, I went back to my original query because this original query has the name in it, and the name is used on their intranet. The employees need to type their person ID, business entity ID, and then they also need to give their full name as a check that they are not checking someone else's. It's not perfect. I didn't set it up that way. I'm just doing what the boss tells me, okay? Don't blame me for this. It's how it works. So here I have the name column back again, but the rest is all unchanged. I'm sorry, this was the copy I needed. The rest is all unchanged. It's the same query, and I can execute it, and I get the data for, well, in this case, I just used a variable, but this will, of course, be a parameter in a store procedure in the final version. And I look at the performance because I know once this goes live, thousands of employees will hit that intranet at the same time and run this query. I want this to be as fast as possible. So I look at the execution plan, and now I see seeks and nested loops joins, which is perfect because I have a very precise filter here. This is just one row. So this is exactly what I want. If I look at the statistics IO, I also see a lot of things I like. There's only one thing I don't like, and that's this logical reach 151 here. Going back to the execution plan, I see that there's one branch that actually still scans an entire table, then does some stuff to eventually filter it down to one row. I don't want this, so I spent some time to create a better optimized version, and that better optimized version does the same thing, but actually avoids the scan does only seeks. And if you now look at the statistics IO, you will see that all these numbers are extremely low. So this is the version that I will dare to put live when the mail goes out and every employee will start hitting the intranet and executing this query. My day is done. I go back home. The boardroom is still busy. And the next day my boss tells me, hey Hugo, we had to make some changes. The 25% change in the commission was too expensive. We had to reduce it to 20%. And then we expect that the sales will go up by 40%. But we don't want to cut the salespeople too hard. So the rate, they won't lose 25% of the payment, but only 15%. And then the 3% for the salaried people, well, that should be 2%. And the 1,800 hours was very unrealistic. It's more realistic to assume 1,715 hours. So you need to change that too. And as you already see, it's very easy to make a mistake when you do that. And I'm now doing that in one query. But now I have to copy my changes to the second and the third and the fourth and the fifth, all copies of the query. And that's why user-defined functions are so great, because I have in one day created 5 almost identical copies of the query with 5 exactly identical copies of this complex logic. And this complex logic is subject to change because the boardroom is meeting about it and trying to work out how it should work. And now I was only changing the numbers, but imagine that the boardroom says, yeah, a 50% increase in sales, that's realistic in America because they're recovering from Trump, they're doing well on the COVID vaccinations, they're on a roll. But in Europe, where the vaccinations are a bit lagging, salespeople will be happy with a 20% increase. And in South America, where there are still some presidents denying the reality of COVID-19, they will probably lose sales, no matter how hard they work. So you need to change this by region. And then I have to join to another table to get the region where the salesperson works. So I have to add a join here, and here, and here, and here, and here, and try to do that without making copy-paste errors, without making sloppy errors, without forgetting any point. And that's why you should preferably, from the point of view of a developer, not have multiple copies of a complex logic. So let's rewind. Let's just travel back in time, roll back everything we've done so far. So we're back at day 1. I'm back at watching my cat videos, pretending to work, and my boss comes to me and tells me, hey, it's that time of year again. And he tells me this entire story. And I'm like, yeah, I know what happened last year. You're going to change those numbers. I'm going to build something reusable. So I go to the internet and I check books online and I find something called a user-defined function. And a user-defined function sounds like just what I need. A user-defined function is, well, there are multiple types, but the easiest to understand, and I start there because I'm lazy, the easiest to understand is the scalar user-defined function, where you pass in some arguments and then you get back a single value. So for instance, the user-defined function to compute the projected commission takes a person ID, the factor with which the commission goes up or down, and the factor with which we expect the sales to go up or down. It then grabs the data from the salesperson table to find what their current commission percentage and sales are, and uses that to compute how much they will probably make next year. Create that function. And then I have a function get projected wage, which also takes a bunch of parameters and then does some tests like, is this person in the salesperson table? Yes, then they are a salesperson. Otherwise, they are not. If they are not a salesperson, then I need to know, is this person salaried or hourly? What is the most recent pay rate? And now we have everything. So now we can do the simple logic for hourly rate, salaried person, or left in for this one for the last, for a salesperson. We do a formula that actually calls the user-defined function that we created here. So let's create this one too. Make sure that we have statistics on. And now the query to compute everything we wanted at first. And I deliberately put in this again. I know that I shouldn't, but I'm just replaying what I did at first with as little changes as possible. So I again make the mistake of accidentally putting in the name. And I run this. And there are the results, and I'm doing some computations, and it all looks awesome. It's all correct, and I'm very happy. And it was really fast, right? So fast forward to when I want the total. I run the total. Oh, wait, before I continue, I do not want the total yet. I want to look at the performance first before I do the total. So let's look at the performance. Well, the execution plan is really simple. Just two tables, read, merge, join, scans. The IO shows that we only use the person in the employee table. It's a bit weird because I know that we use data from other tables, but hey, the optimizer is smart, right? Everyone always tells me Connor Cunningham does a great job. The optimizer is awesome. So yeah, it's awesome. Look what it does. Fantastic. So let's do this total. And it was rather fast, right? It was, wait, what? Why don't I get my results immediately? Why does it take 5 seconds to get results? I thought this was fast. What does the execution plan show? Just a single index scan. Just 92 logical reads. That takes 5 seconds. Something's wrong here. It almost looks like SQL Server is trying to lie to me. Will SQL Server do that? Really? Well, let's take a look. I should have opened this before, but luckily I know where to find it. So I'm going to start extended event session, and I'm going to watch the live data as I run the same query again. This live data will show similar data as we saw here. So we have 92 logical reads here, and here we also see that there are, well, not quite 92 logical reads. There is a bit more logical reads. So there is something weird going on. Let's stop this extended event session. This is a rather lightweight extended event session. This one is not. The one I'm starting now, and they are all included in the demo download, so you can just create this on your own system. It started, I'm watching it. This is not what I would ever do on a production system because it tracks a lot of information. You'll see that as I run this once more. So I'm going to execute the same query again, and it will probably even take more than 5 seconds now, just because of the overhead of this additional extended event session. Well, it was 6 seconds this time, so you see that's about 20% overhead. You don't want that on your production system. And now you see here are the very many logical reads. But if you scroll up, you will see all the statements, and I'm going rather fast, but you will see in the statement column all those statements that are part of the user-defined function. And you will see that there's executed over and over again. So what this extended event session proves is that for every row in the results, this user-defined function is completely executed from start to finish. And each one of those has 2 logical reads, 3, 2, 2, 3, 2, all small numbers. But do that times 29,000 rows and it adds up. Let's make sure not to forget to stop the session again. And now check why this is not visible in the execution plan. So I'm going to return to this one. And remember when I told you that this one ran fast? Well, SQL Server was lying. I was lying too. It seems to run fast because when I start it, you get results immediately. But if you look here, you will see that when I zoomed out, now the screen is frozen. It was still running. And now that it's executed successfully, the total runtime was 5 seconds. The first few rows were there very fast, so it appeared to be fast. But the query didn't complete until after 5 seconds. Now, what you see in the execution plan is only a part of what really happens. So what you don't see, and I happen to know in this case, it's in the compute scalar. So I'm going to look at the properties and I go to the defined values. And if I zoom in here, you will see that at this point, the get projected wage user defined function is called. And that happens for each row. If I look at the execution plan only and not at the execution plan plus runtime statistics, you actually see what's happening. You actually see that here, query 2, it's not query 2, this is get projected wage. It won't allow me to show it, so let's do it like this. This is get projected wage. And if I look here, it says a single execution of get projected wage, I expect that to cost about 0.01 query bucks. Okay, 0.01 query bucks for one execution of get projected wage. I know that here this compute scalar is where get projected wage is invoked. And the estimate is that it will be invoked almost 29,000 times. 29,000 times almost 0.01 is how much? 0.0029. SQL Server here is even lying to itself. SQL Server here is saying, whatever I put in a compute scalar, even though I know that it costs more, I'm still going to pretend it costs 0.000001 query bucks. That's the fixed number it always uses in compute scalar, even in cases like this, where the user-defined function is known to cost more. SQL Server is still going to optimize based on the fallacy of 0.000001, which can even result in terrible execution plans where it is invoked way more often than it should be because it should do a filter first. A lot of stuff already going on. You also may have noticed that the query isn't going in parallel anymore. It's serial. That will always happen. If you have a user-defined function, a scalar user-defined function, all your executions get serialized. User-defined functions cannot be used in a parallel plan. So we already are running into a lot of issues. The rest of this is more of the same. So I'm not going to run this. This is basically the same we saw before. The only case situation where it's not that bad is when you do a get projected wage for a single employee. This runs pretty fast because it's a single row. It will be a single invocation only. However, you can still see that, no, you can't see that, sorry. I was going to say something, but it's not correct, so forget I said it. So we see that a lot of stuff is going on, and the biggest problem is that we have 29,000 executions of a user-defined function, and for every one of those, a single row is found, and there is no way for the optimizer to do scans instead of seeks because they run individually. So the data access in the user-defined function is what kills us the most. There are other issues like no parallelism, but that lack of optimization across execution, that kills us the most. So there is one way you can cheat your way out of that, and that is remove data access from the user-defined function. So what I have here, I'm not going to run all the demos in the interest of time, but what I have here is an alternative version where the user-defined function only does computation. That of course means that we have a lot more parameters to put in, because instead of fetching data based on person ID, we now need to put in all the data. And then we have only the complex logic here. That gives some benefit of having the information and the logic in one place and not having to change it everywhere. But a large part of the logic is this joining. This was a very complex part of the logic where we had to figure out the most recent employee pay data. Remember the ID when perhaps we needed to add the region. That would be yet another join. And again, that would be in the first query, and the second, and the third, everyone. So yeah, this is a way to get user-defined functions to work. And if you have only logic and no data access in your user-defined functions, they still prohibit parallelism. There still is an overhead of calling them, but then they're not that bad. Unless you really need the parallelism, then they're still very bad. As soon as there's data access in the user-defined function, then they're terrible, except for cases where they just only process for one row anyway. But I prefer to avoid scalar user-defined functions for all these reasons. Anyway, I still have my boss who waits for her report. I still want to do that in a reusable way. So I go back to the documentation and I see a more complex alternative method. What I also can do is create a so-called multi-statement table valued user-defined function. And the syntax for a multi-statement table valued user-defined function is you create a function, put in a lot of parameters, and then you say it returns something that is defined as a table, and you specify what the table looks like. With this specification, SQL Server creates a hidden table variable. And somewhere in the logic, you have to insert data in that table variable. So here I'm inserting in a table variable that has this schema. And what I'm inserting is actually a copy with the insert into in the middle of the original query. Remember, let's go back to the original query. And I scroll all the way up. So this query is actually copied to here, except that all the fixed numbers are now parameters. And I insert the results of that into the projected wages return table. That was what I wanted. And now I have created that function. And because this is a table valued function, its usage is different. I do not add a reference in the select list because it doesn't return a scalar value. It returns a table. So the reference to the function goes in the from clause. And here are all the parameters. And now I can just say, hey, give me all the data that comes back from the result from that. And there we get our data. And again, the execution plan lies to me. The execution plan doesn't tell me everything that's going on. Set statistics IO is very incomplete, doesn't tell me what's going on. I can get a better idea to ask for when I ask for an execution plan only, because then I can see the main query does a table valued function that invokes other logic to fill a variable and then reads from that table variable. And that other logic is visible here. And there we see it's still doing the merge joins and the scans and accessing all the data. One problem I do have here, if I, for GDPR reasons, do not show the name, the execution plan will still show that in the last step, or in the actual logic step, the person table is used. So invoking this will populate all those names. And then in the final query, they're simply not read. When I look at the clustered index scan, it will simply say that the output list has only a subset of the columns and doesn't have the name columns. But they are still populated. SQL Server still does the work to get them in that table and then ignores it. The optimizer cannot help me here because of this black box property of the user-defined function. While in the user-defined function, SQL Server doesn't know what I'm going to do with the results. When outside the user-defined function, I have the results, but I have no clue how they were obtained. That's not the worst thing with table value user-defined functions, though. The worst thing is what happens when I do this blame game where I add department. Now, when I execute this query on this small data set, it looks fast enough. But if I look at the messages tab, I already see something weird. In this case, SQL Server doesn't lie or deny it. There's a logical reads of 61,860 on the employee department history, which has only like 200 pages. There's almost 30,000 scans of this table. That's weird. And the reason here is how this all works. Remember, the execution plan gets compiled, and in the execution plan, it says we're first going to populate this table variable, and then we're going to read from it and do logic with it. But when the execution plan is compiled, the table hasn't been populated yet. So the SQL Server has no idea how many rows there were, and it will just put in a sort of random number, 100. On all the versions of SQL Server, that was 1. It was later changed to 100. And as of SQL Server 2017, there is an improvement that I will talk about later. But for now, I'm running this on SQL 2016. This is 100. And based on this estimate of 100, SQL Server says, and nested loops is a great idea here, into a clustered index seek. It would never have produced this execution plan if the estimate had been closer to 29,000. It would also never have resulted in TempDB usage because of a spilling sort. So we see that things go very bad here. And just imagine what happens when this query isn't used by thousands of people at the same time. For each of those thousands of people, the server will populate an internal table with 29,000 rows, and then do a clustered index seek to get just one row from it and throw away the results. And that will happen continuously. My server will crash. This is terrible usage of SQL Server functionality. So I'm almost ready to give up. I don't like my job anymore. I don't like my life anymore. But there's one page left in Books Online, and that reads something like an inline table valued user defined function. It's a terrible long name. I don't like the name already, and it seems complex. It's still the same logic of create function with a name and parameters. And then you just say returns table, but you don't specify what the table looks like. Then you do as return, and then after return there can be just one single query. Yes, a CTE is allowed. It has to be one single query. That's limiting. If you want to do something complex, that means that you might have to do a very complex query. In this case, it isn't that bad. In this case, we already had a single query, luckily, so I could just copy that query. But you're not always that lucky. Now I create this, and it's still returning a table, so the usage is the same as before. But now something weird happens. Now when I execute this using the inlineable user-defined function, I see in the execution plan everything that's going on again. I see parallelism again. I see all the merge joins. I see all the scans. I see everything that happens. This messages tabs tell me all the reads that has happened. It's like we're no longer using a black box. We're using a black box with a glass lid. It's still the black box that we can reuse over and over again. But because of there's a glass lid, the optimizer can peek inside and connect the dots and come up with an execution plan that does all this exactly the way I want it. And that also means, and now we see a real benefit, if I'm going to make this more GDPR compliant, well, in this case, I cannot personally take the person table out of the query because it's not there. But SQL Server can still have the optimizer say, no, you don't need the person table here. We're going to simplify the execution plan, and now you don't need parallelism either because it's a cheaper plan. Now, if I do this blame game by department, SQL Server doesn't come up with a fixed estimate of 100. It gets real estimates and gives me a better plan. Actually, the join to employee department that I added here, employee department history, is somewhere in between the stuff of the user-defined function. It's all mixed and matched together, and the optimizer comes up with a great plan. And when I want to do something for an individual user, SQL Server says, oh, for an individual user, I'm going to do something with nested loops and with seeks and with a very low number of logical reads. So this sounds like the ideal solution for all my problems. I have code reusability and good performance. My life is good. So let's move on to the next demo. Another scenario. You are a database developer for, you know what? You just have a job. That's good enough in these days. You have a job. And at this job, they have a weird setup where locations are always referenced by ID and type, and their names are in separate tables. This is a bit weird. It's not necessarily the best way to set up this scenario, but it's how this company does it, and it's what works for my demo. So I'll set up the database and I'll run this script, and while it's running, I'll talk you through it. So what I have is a table of continents, and each continent has a unique ID, the primary key, and a name. Then I have a table of countries, and obviously there will in reality be more than 6 countries, but I just put in 6 countries as examples. We have states. Not every country has states. In the Netherlands, where I live, I don't have states. In the United States, well, there are states. I put in 6 of the United States as an example. Then this specific company uses areas, and areas are multiple states or multiple small countries combined. So they're somewhere between continents and countries or states as areas of interest, like the Americas or the EMEA region or the Pacific region. Then we have, well, I call them areas, I said Pacific region, but the regions are actually smaller. They are like the European Union instead of all of the European continent, or USA might be broken up into the northwest, the southwest, the northeast, etc. Now, why are all those columns there? Because all those tables there? Because if you look at sales, this company wants to track sales at the lowest relevant level. So a sale made in the Netherlands is tracked as a sale made in the Netherlands. But for a sale made in America, that's such a large country. They actually want to know, was that in Kentucky, or was it in Mississippi, or was it in Ohio? So a sale can be made tracked at a country level or at the state level. And to do that, they have a location
Hugo,
type.
You have 15 minutes to go.
Yes, now. I know. Thank you. They have a location type column and a location ID column. So if a sale is in Denmark, they say it's country number one. Country number one, scroll up, that's Denmark. But if a sale was made in a state, then they don't say it's in country one, country two, which is America. They say no, it's in state one, which is the state of Washington, part of America. And sales can only be tracked at country or state level. They should never be tracked at continent or area level. So there's a check constraint saying the location has to be C or S. We also have a table of sales representatives. And sales representatives may have an area of responsibility equal to a country or a state, but it might also be an area or a region, depending on their position in the hierarchy, how senior they are. They may have a smaller or a larger area of responsibility. So you may have a sales representatives for region number 3, which is the northwest of USA, or for state number 6, which is the state Kentucky, or for area 3, which is the entire Pacific area, or just for the country Sweden. Then we have our directors, and directors, of course, are not focused on single countries or states. Directors are only focused on areas, regions, or continents. So for directors, we also have the same combination of location type and location ID, but now with a check constraint that it has to be A, R, or O. Yeah, sorry, the O for continent. I didn't design the English language. The C is already taken for country. Blame it on the English with a bad language. I hear someone in the background speaking French. If you want to speak to me, you need to switch to English. And if you're not speaking to me, then please mute yourself.
Yeah, I will do it. It's not a question. If it's a question,
in the demo, I also added 2 fake regions and 3 fake areas because I wanted to have 6 of each. The reason of that is that I also have for performance tests a big table which is not tracking anything really in the country in the company, that allows all location types, and where I just use a random 1 to 6 number and a random of each of the 5 types to just populate with random data, because I don't care what's there. I just want to have 10,000 rows in there. And all of this to test the performance for my solution, which is, of course, a user-defined function to simply get the name given a location type and a location ID. Now, I don't want to do this with a scalar user-defined function. I already learned SQL Server is bad at scalar user-defined functions. I don't want them. But I still start with a scalar user-defined function in this case, just as a way to get my thought process going. Because a scalar user-defined function has the benefit of simplicity. I can here just type what I mean. It's really simple to understand what's going on. I want to get a location based on location type and a location ID. So I have a location as the output. And if the location type is a country, then I get the country name from the countries table based on the location ID. If the location type says no, it's a state, then I do the same with the states table, and so on. A very simple logic in this user-defined function, and then I return the location. I can create it, and I can then use it, but really it's not interesting. It works, of course, and we already know that in the execution plan we will not see the complete reality. We will be lied to, and we're not going to use this. But now we have at least our baseline of what are we trying to do. This is what we're trying to do. Now, we actually want to go to an inline table valued function because that's the only solution that works, right? So we want an inline user-defined function. And for an inline user-defined function, we have to put the logic into a single query. So let's try that first. And I'm going to start with the fake table called big table, because the big table is the most complex one. It has all the 5 levels of geography we have. So what I do here, and this is perhaps the most complex query shown so far, So I'm going to talk you through it. I just grab all the rows from the big table. Then I'm going to do a left outer join to the countries table. And a left outer join only produces a row if there is a match in the on clause. In this case, the on clause says the country ID has to be the location ID. That makes sense. And now, and this is weird because I reference not a column from the countries table itself. I reference a column from the big table, has to be the same as a constant. So if I'm processing a row from big table that is not for a country, then this join will never, ever, ever produce a row. It will always produce nothing because I'm processing a row where big table dot location type is, for instance, S. But you can try every row in the countries table, but the T dot location type will never change. And I do that with all 5. So what effectively happens, let's assume I'm processing a state. I have a row in the big table that happens to be a state, so location type is S. This left join will produce nothing, but it's an outer join, not an inner join, so the row is not removed. This join does produce the data from the states column, so here we get actual data. And the next 3 rows again produce nothing. So we have data in this column and no data in the other columns, and the coalesce ensures that only the non-null value is returned. So the final result of this is exactly what we want, at least if you're in the correct database. It's exactly what we want. Every big table ID with the correct location name. I didn't even include the ID and type, which I could have done for verification, but this is correct. I debugged this, it's correct. And you can see that the number of logical reads is really low everywhere because it uses hash matches and scans. So it's a very effective method as well. And I can use the same method for all the other tables. If I want to do the same on the sales tables, I just, instead of using big table, I use the sales table here. I could, of course, remove this. I know that there will never be a match because sales is only countries and states. But even if I don't, even if I let it in, SQL Server will still only process the tables it needs. And if you look at the execution plan, don't look at the nested loops here. They are nested loops and not other joins because there's just 2 rows. If I add more sample data, I will get merge join or hash match join. So don't look at the nested loops. That's just because I was lazy preparing the demo. What you do want to see is we process the sales, the countries, and the states table, but not the rest. SQL Server knows, because the sales table has a constraint on location type saying check location type in C or S. Because of that, the optimizer already knows that this part will never do anything, and effectively it removes it from the query before optimizing. Now we have our single big query, so now we can create an inline user-defined function by copying that query. And that works. So we have an inline user-defined function, and we can use it. There's only one problem with this user-defined function. It references the big table as part of the user-defined function. So I cannot use this user-defined function to get data from the sales table. Then I have to create a new copy of that same function based on the sales table. And I have to create one for the directors, for the sales reps, and all others. So I'm not actually reusing code. I'm still copying code. I'm just hiding it better. So yeah, technically I'm using a user-defined function, but I don't get the benefits. Because if anything changes, if at one point someone says, no, the O for continent is actually a bad name, it should be a T, well, I have to change it here, but also here and in all other copies. That's not going to work. So how are we going to solve this problem? And the solution is, I already pointed out a few times how SQL Server is lying to us, remember? Well, we're going to repay SQL Server. I'm going to lie back. What I'm going to do is I am going to lie to SQL Server. And this query looks complex, but it's actually very similar to this query. The only thing I changed is instead of getting rows from big table, I'm getting rows from a table source that I create on the spot using the parameters passed in. So this is a single row. This is a table source that is just a single row and 2 columns. Then I apply the same logic I used on the big table, but now just on that single row, and I return something. And I return just a single column. So if I look at this, I know that whatever I put in, the result will always be one row and one column. I call that a scalar. I call that a single value. However, I use the syntax returns table. So I'm telling SQL Server, no, I'm going to return a table. Really? Don't tell SQL Server. It's always one column, one row. It's just a scalar. I've created this, and now I can test it and say, give me the name for country number 1, and I get the name back. Cool. A problem is if I try to add this in an actual query, so I want sales, and then for every sales row, I want the location inline of the inline version of the get location function based on location type and location ID, and I will get an error. The problem here is that join is in a from clause. The from clause is supposed to be not ordered. So I cannot use anything here that refers to this part because the order is not defined. SQL Server is free to reorder this. So that's just a part of how the SQL language, the SQL language is defined. It's in the ANSI standard. So it's not like SQL Server or Microsoft chose. So this is the ANSI standard. So what Microsoft did was they said, we're going to introduce a new keyword. This is not ANSI standard. It's just an extension that Microsoft created. We use it cross apply. It works the same as a cross join, except that now you can refer to something that is before, because now we have an ordering defined. It's still a logical ordering. The optimizer can still get as creative as it ever wants. So it's just a different way to phrase it so that we get around the limitation in the ANSI standard. And this works. And if I do this for instance, the sales table, you will see that it still doesn't access any tables it shouldn't access. If you look at the execution plan, it might appear that it accesses other tables as well, because you see the contents table here. But here it uses a filter with a so-called, with a so-called startup expression predicate, which says if this is not true, then don't even bother executing that. So instead of having the optimizer cut out the access to the contents table, it's now made conditional so that at runtime it's cut out. And this gives us a good performance across the way. If you look at the last one, I'm not going to show it. It's slightly slower than the original version, but that's a small price to pay. It's still very acceptable performance, and we have the benefit of reusability. So let's wrap this up. Scalar user-defined functions kill performance. Don't use them. They're always invoked once per row. That's overhead. You don't have parallelism. You have no good optimization if there's any read access in the user-defined function. There's one thing I do want to point out in SQL Server 2019 as part of intelligent query processing, a feature called Scalar User-Defined Function Inlining was introduced. I was very excited about this. I also have it in some of my other sessions where I talk about the benefits it brings. However, after it was released, some very nasty bugs were uncovered, and they were serious enough that Microsoft has disabled Scalar User-Defined Function Inlining in Azure SQL database. To the best of my knowledge, this has still not been resolved. I expect that one day it will be enabled again after all the bugs have been fixed. If you are interested in running user-defined functions on SQL Server 2019, the box product still has it enabled. Check what you can find in the documentation about the bugs, check that you are not affected, and then use it. It actually is a good improvement. Before SQL Server 2019, Scalar user-defined functions are always bad. Multi-statement table value user-defined functions, apart from being a hell of a task to pronounce, also kill performance. They have to be completely evaluated before the rest of the plan is executed. They store all the results in TempDB and are then read back, possibly wasting a lot of effort if you don't even need all the results. And then you have this weird cardinality estimate, which used to be one row until SQL Server 2012, changed to 100 in SQL Server 2014. In SQL Server 2017, a feature called Interleaved Execution was introduced that in some very specific cases improves this a bit. It's very specific and it doesn't touch most of the use cases for table values user-defined functions, so don't rely on it. But it is there, and if you want to read more, read up on interleaved execution. Inline table value user-defined functions are okay. They work similar to a view, but with a parameter. So the definition is substituted for the name, and then the optimizer can optimize. But you need to use apply instead of join, which is a bit harder. It still takes some of your control away, and the conversion can be a challenge. If you have a multi-statement user-defined function and you want to convert it to inline, your performance will increase, but you will have to put all the logic that's currently in those multiple statements into a single query. If you currently have a scalar function, then you also have to change all the calling queries because the table valued function is called different. That's a one-time effort. After that, you have this reusable user-defined function that you can change if the business rules change, but it can be a lot of effort if it's a function that's used across the board. But it will give you better performance. So that's all I have time for. I'm even 1 minute over time, so I'm going to tell you questions. Please mail me, tweet me. I'm happy to field any questions you may have. And I thank you all for your interest. And I wish you, I think there's one more session coming after me. So
yes, just thanks a lot, Hugo.
I wish you a
I don't know
wonderful
if there are questions now. If people
is there time for questions? Because I know I'm 1 minute over. I don't want to
no. If it's just 2 minutes more. But
okay, I'm happy to answer questions if there are any.
So it seems not. But I encourage people to go to your site and look at all the information you give on the query plan, execution plan.
Thank you.
It's very comprehensive and valuable.
Good.
Thanks to you.
And if you're interested, remember, if you want to look at the video training, remember the code was DataFrogs with capital D, capital F. I think it's case sensitive. I haven't tried. Thank you. And thank you, Rudy, for putting this together and for inviting me.
Oh, thanks to you to have come.
Thanks,
that was perfect.
And we still need to catch up on drinks once this COVID misery is over.
It's not possible right now.
We still have we still owe each other lots of drinks. We should not do that on one day.
That would be great.
Not on one day. That would be terrible.
Not in one day.
Thanks a lot. Seem great. Thank you and good luck with the rest of your conference.
Have a good weekend.
Bye bye.